Solve. All right, so for example A, it looks like we have 3 terms here in the problem. And that means if we took the ln of both sides, it wouldn't be very helpful. We'd end up having ln of a difference there, and that wouldn't really be very helpful because we don't have a way to simplify the ln of a difference. So what we're going to actually do instead, taking the log of both sides, is we're going to consider the fact that it has 3 terms in the equation, and then look at this little guideline which says when an exponential equation involves 3 terms, consider if it is in quadratic form. What I mean by that is we're going to try to make the middle term here, this 2 to the x, equal to u, and see what would occur if we did that. So what would happen if u was equal to 2 to the x? Well, then u squared would be the idea of squaring 2 to the x, and if we square 2 to the x, these exponents multiply together, right? Giving you 2 to the 2x power. So that'd be 2 to the 2x power there. And that is our leading term in the problem. That means we can substitute 2 to the 2x for u squared while substituting the 2x for u, and that would be equal to 21. Now this is a quadratic equation which can be solved. I'll bring the 21 over, making it negative 21, right? And then we'll have factoring that will allow us to solve the problem. So we'll have u and u, factors of 21 that subtract to give you 4. I think that would be 7 and 3, right? Since it's a negative 21, we'll have a sign of each. The negative sign being on the larger number, so we end up with a middle term that's negative. So we'll have u minus 7 times u plus 3 is equal to 0. That means that u minus 7 is equal to 0, and that u plus 3 is equal to 0. And then finally we'll end up saying that u is equal to 7, in other words, and u is equal to negative 3. All right, and if that's true, we've solved for u, but we haven't solved for what we're looking for, which is x. So we need to back substitute. Remember, u is equal to 2 to the x. So we'll have 2 to the x is equal to 7, and we'll have 2 to the x is equal to negative 3. Now, it's not possible for 2 to the x to be equal to negative 3, is it? Is there any power you could put in for x that would make 2 suddenly become negative? I don't think so. That's not solvable, so we're going to cross that out. That's an extraneous solution. But the 2 to the x equals to 7 does have a solution. If we take the ln of both sides, we'll end up getting that exponent down. So we'll have ln of 2 to the x times ln of 7. The exponent can come down as the coefficient here. So we'll have x times ln of 2 is equal to ln of 7. And then we can divide both sides by ln of 2 to isolate the x. And sure enough, we can get our answer then, that x is equal to ln of 7 divided by ln of 2. Very good. Let's take a look at b then. For b, you might be tempted to say, oh, that's again in quadratic form, but if you look carefully, it's not the same as what we had before. For example, there's no 2x power here, right? It's 4 to the x, not to the 2x. And then we have a negative exponent here. That's a little peculiar. We don't like negative exponents, really. So what we want to do is factor out that term that has the negative exponent. So we're actually going to pull out that 4 to the negative x from both terms in the left-hand side. So if I pull it out of 4 to the x, what happens? Well, basically remember factoring is like division, right? So if you were to do 4 to the x divided by 4 to the negative x power, you keep the base and subtract the exponents. X minus a negative x becomes x plus x, or 4 to the 2x, right? Because x plus x is 2x. And of course, for the second one, if you pull the 4 to the negative x from itself, it ends up just giving you 1, right? Because 4 to the minus x power divided by 4 to the minus x power is just 1. So we'll end up with negative 1. And that's equal to 2. Now, we want to get rid of that 4 to the negative x because it's not very helpful, so we're going to actually multiply both sides of the equation by 4 to the x. What that's going to do is get rid of the 4 to the negative x, because when you multiply things with the same base, you add the exponents. And if I add x to negative x, I end up with 0. So we get 4 to the 0, which is the same as just 1, right? Okay, so this on the left-hand side will just become 1 times 4 to the 2x minus 1 is equal to 2 times 4 to the x. Now from here, if I were to bring this piece over, we have an equation that's in quadratic form, because I'll end up having 4 to the 2x power minus 2 times 4 to the x power minus 1 is equal to 0. And then if I use that u substitution idea, if I say u is equal to 4 to the x, and therefore u squared is equal to 4 to the 2x, I can substitute in here saying that u squared minus 2u minus 1 is equal to 0. All right, and then you would try to factor, but it turns out that, of course, a negative 1 here means you're looking for factors of 1 that subtract to give you 2. There are no factors of 1 that subtract to give you 2, so that means that won't work for us. We're going to actually have to use quadratic formula on this thing. So no big deal. Quadratic formula would be that u is equal to negative b, or in this case, negative 2 or positive 2, plus or minus the square root of b squared. The b term squared would be 4, minus 4 times the a term times the c term, all over 2 times the a term, or just 2 times 1. All right, that'll end up giving you 2 plus or minus the square root of 4 plus 4, right? Because negative 4 times negative 1 is positive 4. That'd be 8 over 2. And this will end up being 2 plus or minus 2 square roots of 2, because 8 is 2 times 4. The 4 comes out as a 2 over 2. Then you can cancel out these 2's to end up having 1 plus or minus the square root of 2 as your answer. So that means that we actually have two answers for u. We have that u is equal to 1 plus the square root of 2, and that u is equal to 1 minus the square root of 2. Remember, in this problem here, we said that u is equal 4 to the x power, so we'll have 4 to the x power equals to 1 plus the square root of 2. And on the other one, we would have had what? 4 to the x power is equal to 1 minus the square root of 2. It turns out that 1 minus the square root of 2 is actually a negative number, because the square root of 2 is bigger than 1, right? It's like 1.4 something, right? And so that would end up giving you a negative answer. Remember, 4 to the x power can never be negative, because no matter what power you put in on 4, it's not going to suddenly turn into a negative number. So this can't be solved. So we can throw out this answer. That's not an answer we can find. But we can use the one that says 4 to the x is equal to 1 plus the square root of 2. We can solve that by taking the ln of both sides. So we'll end up having ln of 4 to the x is equal to ln of 1 plus the square root of 2. And then the x can come out in front, multiplying here. So we'll end up having that x ln of 4 is equal to ln of 1 plus the square root of 2. And finally, divide both sides by ln of 4 to finish. Ln of 4 into that, ln of 4 into this. The ln of 4 cancels out to give you just 1, and so 1x is equal to the ln of 1 plus the square root of 2 divided by the ln of 4. All right, that was a difficult one, but that's the final answer for B. All right, let's go ahead and look at examples C and D then. All right, for example C, again, we have a similar sort of thing. We want to use quadratic form because we have 3 terms in the equation. In order to use u substitution, though, we really needed something that says 2x in there or something like that, right? We don't have that, but I certainly can see that, the 9 here can be rewritten, right? It should be able to be something like 3 squared, and if I did that, what would happen? Well, if you take 9x and write it as 3 squared to the x power, then these two can multiply to say 3 to the 2x power. So we can replace 9x by 3 to the 2x power. So let's go ahead and do that. We'll have 5 times 3 to the 2x power minus 14 times 3x plus 8 is equal to 0. And then if we have that, we have just u substitution again. So let's go ahead and let u be equal to 3 to the x. And therefore, u squared will be equal to 3 to the 2x power. So we're going to use that for u substitution. So we'll end up having 5 times u squared minus 14 times u plus 8 is equal to 0. So in order to solve that, we're going to go ahead and try to factor it if it's possible. So we'll have 5u and then u. All right, so then we're going to try to factor the 8. So think of factors of 8 that might work here. For example, we could try 2 times 4. So I might try 2 here and 4 here. If it's positive here on the right, it means 2 negatives, so negative, negative. Let's check that. It'll be negative 4u and then negative 10u. That does give you negative 14u, so our factoring is correct. Then you want to separate those terms and set them equal to 0, right? The zero factor property says if you have a product and the result is 0, the two terms can be separated. The two factors can be separated and set equal to 0 separately, right? So we'll move the 4 over here, saying 5u is equal to positive 4, and u is equal to 2 for the other equation. U is equal to 2 is done. For the other one, we divide both sides by 5 to finish it up. and we have that u is equal to 4/5, or that u is equal to 2. Now remember, u was just what? 3 to the x. So we're going to change this then to 3 to the x is equal to 4/5, and 3 to the x is equal to 2. Let's take the ln of both sides then. If we take the ln of 3 to the x, we'll have ln of 3 to the x is equal to ln of 4/5. Bring down the x as a result, so we have x ln of 3 is equal to ln of 4/5. And then finally divide both sides by ln of 3 to finish. So that's one answer to the problem. And let's look at the other one. For the other one, we take the ln of both sides. So ln of 3 to the x is equal to ln of 2. Bring down the x as a result, so we have x ln of 3 is equal to ln of 2. Then divide both sides by ln of 3, and we finish it up. All right, so finally x is equal to ln of 2 divided by ln of 3. You can check both of those answers, but they do indeed both work into the equation. All right, so let's try the last one then, example D. So example D has 36 to the x power minus 6 to the x plus 1 power is equal to 16. All right, so again, it has more than 2 terms in it. It's an exponential equation with 3 terms. We might want to consider trying to solve it using the quadratic form approach. But I don't have the same base here. I have 6, I have 36, but we know we can rewrite 36 certainly, right? So let's try to do that. If we rewrite 36, for example, as 6 squared, then if it's raised to the x power, it'll become 6 to the 2x power. So I can rewrite 36 as 6 to the 2x power, and there's that familiar 2x exponent. So let's do that. We'd have 6 to the 2x minus 6 to the x plus 1 is equal to 16. But that's not quite the same as we used to have, because we used to have 6 to the x in the middle, something like that, right? We'd have something to the x power, and then in the front we'd have something to the 2x power. And here in the middle we have x plus 1. That isn't quite right. But remember, we can rewrite that as what? 6 times 6 to the x, because when you have a common base and you add the exponents, this would be the same as saying 6 to the x plus 1 power, so I can just say it's 6 times 6 to the x. So I should be able to rewrite this again as 6 to the 2x minus 6 times 6 to the x is equal to 16. All right, and then we can make this into quadratic form. If I go ahead and let u be equal to, in this problem, 6 to the x, then u squared would be equal to 6 to the 2x, right? So we'll use this idea to help us rewrite it. So 6 to the 2x is u squared minus 6 times u is equal to 16. Bring the 16 over, we'll have u squared minus 6u minus 16 is equal to 0. Then we'll try to factor it if it's possible to do so. So it'll be u and u, factors of 16 that subtract to give you 6. 8 times 2 subtract to give us 6. And since it's negative, we'll have to have maybe the 8 negative and the 2 positive, right? And if we check this, of course, we do see that it works out, right? Okay, so that's the proper factoring. And we'll have that u minus 8 is equal to 0, or that u plus 2 is equal to 0. That means that u is equal to 8, or that u is equal to negative 2. All right, so remember, u is the same as 6 to the x power, so we're going to say 6 to the x power is equal to 8, and 6 to the x power is equal to negative 2. Now, it doesn't matter what we make x, we're never going to be able to turn a positive 6 into a negative 2 just by putting an exponent on it. So this cannot be done, so we're going to cross that one out. But 6 to the x is equal to 8 can be solved. Let's take the ln of both sides, for example. ln of 6 to the x is equal to ln of 8. If I do that, the x will come down in front, giving me x times ln of 6 is equal to ln of 8. Then at that point, I can divide both sides by ln of 6. The ln of 6 cancels out, and I end up with x is equal to ln of 8 over ln of 6. And if you check that, that works out, so we're done.